So here we are again in part 3. We have done we've done part of the conceptual work here of translating to store passing style. In particular, we have completed the transformation on this vec swap, and now what we need to do is to push this through all of the rest of the functions. In order to do this, we're going to need a plausible test case. And in order to do that, we're going to need a vector to sort. Let's put this test case at the bottom. Representing these vectors is now going to be a little painful, so I think I'm going to do just one big test case. I'd like to model a vector, and let's say it's got 4, 12, 3, 19, let's say another 12, and a 5. Okay, and after sorting this, we're hoping that it's going to be, let's see what we got here. How about, look, we're doing a bubble sort. Not quite. Well, we basically are. The 19 is going to go all the way to the end. The 12. Okay, great. 3, 5, 12, 12, 19. That's what we want. We want it to look like afterward. But now, in order to call our quicksort, we're going to have to represent this as a mu-vec, which refers to a store. As before, we're going to imagine that this is a mu-vec to somewhere in middle memory, just so that we don't accidentally imagine that all vectors are references to location 0. Okay, so I need a store that has this stuff in it. So just like we did before, we're going to model this as a mu-vec to location, again, let's pick something random, 322, and it's going to be of length 1, 2, 3, 4, 5, 6, 6, and now we need to actually write down the store that contains this stuff, and it's going to look like this. List values 322 has location 4, and in fact what we really want is to just decorate these guys. I'm going to copy these guys here, and we're going to paste them here, and then we can just wrap them one at a time. Values 3 and 23. Whoops, sorry, that one. That was supposed to be 323. Values 323, and this one is values 324. Sorry, yeah, it was 324, and then this one's values 325, and this one's going to be values 326, and this one's going to be values 3 and 27. Okay, there's the state of the store beforehand. Now, what should it look like after we're done sorting? Well, in fact, the return value should be, the vector is essentially unchanged. We're sorting it in place, and what's going to happen is that we are instead going to change the values held in each location. The store is what's going to change. Afterwards, what's the store going to look like? Well, it's going to have a sorry, we've got that guys right down here. It's going to be a 3, and then a 4, and then a 5, and then a 12, and another 12. That one didn't move, and a 19. Yep, 19. And that's what it should look like afterwards. So in other words, if we call it with these values, if we call our quicksort, right, quicksort of these guys, the result should be this store. All right, here we go. Test. Quicksort of this should be this hash. Okay, now immediately we run into a problem. Quicksort is undefined, right? That's because we commented it out. Let's stick it in here. Okay, here's the first thing that I want to think about. Quicksort here, it doesn't return a store, it returns the vector. Now, this isn't totally necessary in this case because the vector is unchanged. At least it still contains the same pointer and the same length. But in fact, this is a problem we're going to run into a couple of times. We are going to have functions that do genuinely want to return a value. So for instance, in your assignment, it's going to be the evaluator is going to nearly always want to actually return a value. What this means is that we are now going to have to return a value and a store. In this case, a vector and a store. How are we going to return two things? Well, the answer is we're going to have to come up with a structure that represents those two things. Represent a pair of a mu vec and a store. define type vec and vec cross store is v cross s containing v, which is a mu vec, and s, which is a store. We now have a kind of data that we can use in order to represent the return value here. So let's deploy it here. What we're basically saying here is quicksort is not going to return a vector of a number anymore. It's going to return a vec cross sto. All kinds of things are now failing to type check. That's okay. Let's patch up the rest of this line, and then we'll go and make sure the test case makes sense. So our vec is no longer a vector of number. It's now mu vec, and we're passing in a store and returning both the vector and the store. Okay. The body of this function, again, it's a total mess. That's okay. Let's go check out the result down here. The result of this guy should now be a v cross s containing this unchanged mu vec and also the extremely changed store. All right, this test case now matches our contract. Let's go back up to the top and take another look at quicksort. Okay, so quicksort now is going to call this helper function with a store, and currently that returns absolutely nothing, which is totally fine with us. What we're going to do now is have it return a store. And just to reiterate this, nearly everything that wants to perform, that could perform mutation, must now return a store. So what we're going to do here is we're going to say store2 is going to be this guy. Oops. And now we're going to return v cross s, thank you, s, thank you, please, s of vec and store2. Okay. So that all looks great. This is done, except that unfortunately we haven't yet modified quicksort helper. So let's bring quicksort helper back into the picture, and of course everything is going to break horribly. All right, quicksort helper is now actually going to return a store. Since quicksort helper didn't really return anything beforehand, we don't need to return a pair of values in this case. The only thing we're returning now is the store. So here we go. Let's just truck on through this and see how everything has to change so that stores get properly propagated through this process. They have to trickle through. Here's the first thing that we can see when we are done, which is to say we've reached the base case. This array is of length 1, or the region that we're interested in is now of length 1. We're going to return the store. I see here, look, I forgot to change this to a mu vec. Sorry. And okay, great. This looks good. Now what you need to do for each of these is to look at these and figure out which of them could mutate the store. This first one, no, definitely not. The second one, no, but it's going to need the store. All right, so instead of a vector ref, we now have a mu vec ref of this, and we have to pass in the store. But no change can possibly happen to the store here, so we're good. First larger posin. Now take a look at this one, the do quicksort loop 1. This function returns something, and it also could mutate the store. What that means is it's now going to have to return a pair of values. Just like quicksort returned a mu vec and a store, this one returns a number and a store. This means we're going to have to be able to represent this one as well. Represent a number, a pair of a number and a store. Define type. This is going to be a num cross sto, and we'll call it n cross s, and it's got n, which is a number, and it's got s, which is a store. Okay, this is bothering me, sorry. So now we've got this notion of a num cross sto, and what we're going to have to do is quicksort loop 1 is going to have to return a num cross sto. Let's go ahead and update the type for quicksort loop 1 before we do anything else. So we have a picture of what's going on here. Vec is going to change to mu vec, and it's going to return now a num cross sto. Okay, I'm just changing the type here. Quicksort loop 1, we're going to bring this one in as well, and this one is also going to return it's going to accept rather a mu vec and it's going to return an num cross stow. All right, the types look good here. Everything else looks horrible, and that's fine, no problem. We want to go back now to the, this thing's bugging me now. Line 48, muvec? You don't like the type muvec. Oh, look, I spelled it wrong. Okay, muvec. Sorry about that. Okay, great. So we're now looking at quicksort helper, and in particular, we are trying to run through this and take a look at what's going to happen here. So this in particular, this call right here is no longer going to return a number. It would not do simply to say define this posin to be this thing here, unfortunately. What we're going to have to do is to take this return value apart into two return values. So it's going to have both the number and also the store. At the risk of making this even more confusing, the easiest way to do this is just to change this name, probably. So this first larger posin is now first larger posin and also cross stow. Okay. So first larger posin, this thing now contains, sorry, let's call it stow 2. This is a funny looking name. There's nothing special about a star. This is all just one big name. It now is a num cross stow. It contains both a number and another store. All right. So this part down here looks fine, but now what's going to happen here? What's going to happen here is we no longer want to pass this first store. Instead, we've got to pass the new store that we got out of this call. In order to make this a little clearer, let's pull these out and give them names. Define store 2 to be n cross s hyphen stow, I think it's called. No, it's called s. There it is. Of first larger posin cross stow 2. All right, so we're pulling out the store piece of this. We should also pull out the number piece of this so that we can use that. Define the old number, the first larger posin, to be n cross s hyphen n, the number part of this piece here. Okay, just to review this one more time. This call used to just return a number. Now it's returning a pair containing a number and another store. And now down here, we're extracting those two pieces. This is the number, this is the store. Okay, down here in quicksort helper, we no longer want to use store. We now want to use store 2. I want to draw your attention to this because this is it's really an easy mistake to make. And unfortunately, the type checker won't help you with this at all. In fact, it's quite hard to catch these bugs. If I accidentally use stow instead of stow 2, I'm going to get some fairly mysterious bugs. In particular, what's going to happen is the changes to the store that were supposed to have occurred in quicksort helper just won't happen. Okay, so now the result of this thing, quicksort helper, is going to be another store 3. Store 3. All right, and when we now make the final call to quicksort helper, we need to be sure and pass in that store 3, stow 3. Okay, so we may have type checking errors elsewhere, but this actually looks like a correct definition of quicksort helper to me. What we have done here at the high level is this. We have found there were 3 calls in here which could update the store. This first larger posin, this call to do quicksort loop 1, and also this call to quicksort helper, and also this call to quicksort helper. For each of those, we need to make sure that we take the store that is returned and use it as an input to the next computation, or simply return it, as we did in the last case. So the store that comes in at the beginning is now passed into quicksort loop 1, and this thing produces store 2. Store 2 then flows into, let's hit the return so you can see this, then flows into this quicksort helper, and the result is store 3. Store 3 then flows into this thing, and then that result is simply returned. Okay. Okay. So we're now ready to move along to the next function. However, I'm pretty much out of time. This is step 3. Let's just scan forward and see what work remains to be done here. In quicksort loop 1, let's take a look at the calls that are going to affect the store. This one is going to affect the store, and then also this one is, and then also this one is. However, notice something that's nice. In this one, the call to the loop thing is actually in what's called tail position. It's the last thing to happen in this. Therefore, there's no more threading to do. There's just one call and then return that pair. The same thing is true here. So neither of these is going to require interesting treatment. Specifically, the store that flows into this loop here is going to be the right one to flow into this recursive call, and also going to be the right one to flow into this recursive call. That is, this store is used either here or here or here. This one here, we will have to do at least a little bit of work on, but in fact it's very simple. All we need to do is, since this thing here returns the new store and no other value that we're interested in, all we need to do is to bundle this piece with the next one. Okay, look, I'm so close here. Let's just finish it out, shall we? Yes, let's finish. Let's finish. Okay, so all I need to do here is to swap these two and then bundle them up as an n cross s. And now, in fact, we don't even need this begin anymore because there's only one thing in it. Okay, that looks great. That also looks great. That also looks great. Boy, we are doing great here. I'm hoping this one here is going to be similarly easy. Yes. Pretty much yes. Okay, let's take a look at this one. This guy here, this is just an n cross s, and then we're going to switch the order of these two. So it's an n cross s of the first, and then let's do this swap to produce the new store. That's excellent. This one here is a call to a possibly mutating function, but again, it's in tail position, so we're good. Now, here, this one, we could be in a bit more trouble. Yes, we are. Specifically, we need to do the vector swap and then do something else. Okay, so what we're going to have to do here is we're going to have to grab this guy and give it a name. Let vecswap, fortunately, vecswap just returns a store. And so all we need to do, whoa, wrong way around. All we need to do is get this guy, call it store2, and then we need to use the new store, store2, rather than store1 in this call back to the first loop. Okay, I think we are good to go there. And actually, I think we might be very close. As I said before, I think we can finish this guy out. It looks like there are some very minor problems where oh boy, I think the dictation got engaged there. Help! This is no longer vector length. What we need is something called muvec length. All right, and muvec length is not defined, but in fact we know what it is. It's just muvec hyphen, actually muvec len. Is that what we called it? I think we just called it muvec len. Let's now find out why it is that the type checker is unhappy by running this program. And the problem is, oh look, we have another vector ref. What we wanted here was muvec ref, and of course that's going to require us to pass in the store. Since this cannot mutate the store, we don't need to worry about all of the inside-y, outy stuff. We can just cheerfully pass it along, and we're fine. And let's find where the next type checking error is. We have another vector ref here, and this one also can change to muvec ref, and must get store. And now we're purple, which looks good in the lower right hand corner. You can see down here we're happy and we're type checking. Let's go ahead and run it, and if I'm very lucky, and I was, it actually returned the right value. Okay, we have successfully converted this program to store passing style. This is the end. It's time for me to go. Have a wonderful day.